Welcome to Surveying and Geospatial Insights, the podcast that charts the course of the measurement sciences. I'm your host, Survey Steve. For generations, the core of our profession has been the meticulous collection of measurements to define land, property, and infrastructure. But the ground beneath our feet is shifting, technologically speaking. Today, we are looking forward to discuss a topic that is both exhilarating and, for some, a little daunting: the future of surveying. We'll be exploring the new technologies, the changing roles, and the essential skills that will define the next generation of geospatial professionals. Joining me to navigate this future landscape is my colleague, Debora. Welcome.
Thank you, Steve. It's a critical conversation to have. We are truly at an inflection point. The tools and workflows that defined surveying for the past few decades are being augmented and, in some cases, replaced by a wave of innovation. The future isn't about whether surveyors will be relevant. It's about how we will redefine our roles to be more essential than ever.
Let's start with the most visible part of this transformation: the technology of data capture. The robotic total station and RTK GNSS receiver are still workhorses, but they've been joined by an incredible array of reality capture technologies. We're talking about terrestrial laser scanners that capture millions of points per second, unmanned aerial vehicles or drones equipped with LiDAR and photogrammetric sensors, and mobile mapping systems mounted on vehicles that can survey entire city corridors at highway speeds.
Exactly. And the trend is towards sensor fusion. It's no longer about choosing between photogrammetry or LiDAR. It's about integrating multiple data streams into a single, comprehensive data set. We're seeing the rise of technologies like SLAM, simultaneous localization and mapping, which allows for mapping in GPS-denied environments like building interiors or underground mines by using LiDAR and imagery to build a map as the device moves through the space. The result is an explosion in the volume, velocity, and variety of spatial data we can acquire.
That's an incredible portfolio of tools, but integrating data from a terrestrial scanner, a drone, and a SLAM device sounds like a monumental challenge. How do we ensure that a point from one sensor in the morning relates perfectly to a point from another sensor in the afternoon?
That's a critical point, Steve. It's about geodetic control. The fundamental principle of surveying, working from the whole to the part, doesn't disappear with new technology. It becomes even more vital. We must establish a robust, high-accuracy control network that serves as the single source of truth for the entire project. This network, established with the most precise static GNSS or total station observations, becomes the skeleton upon which all other lower accuracy data from drones or scanners is fleshed out. Without that strong geodetic foundation, you're just building a beautiful-looking but spatially unreliable house of cards.
This data explosion creates its own challenge, which leads to the next major technological shift: data processing. A single day of mobile mapping can generate terabytes of point cloud data. Processing that on a single desktop computer is no longer feasible. This is where cloud computing has become a game changer, allowing for massive data sets to be processed, stored, and shared collaboratively across distributed teams.
And processing is getting smarter. We're seeing the rapid integration of artificial intelligence and machine learning into our software. Instead of a technician manually tracing features in a point cloud, AI algorithms can now perform automated feature extraction. They can identify, classify, and model objects like curbs, utility poles, vegetation, and road markings with incredible speed and increasing accuracy. This doesn't just save time, it allows us to derive insights from data at a scale that was previously unimaginable.
That's a fascinating point about automated extraction, but it also raises a crucial question of quality control. An AI might identify a curb, but can it understand the legal significance of that curb as property line evidence? How does the surveyor of the future ensure the integrity of these automated outputs?
That's the million-dollar question, Steve, and it's where the professional surveyor's judgment remains irreplaceable. The answer lies in a multifaceted approach to quality assurance and quality control, or QBIC. First, the surveyor must understand the entire workflow, from sensor calibration to the parameters of the processing algorithm. They can't just trust the black box. Second, the results must be validated against independent, high-accuracy ground truth data. This means having skilled field crews still go out and capture a statistically significant number of check shots with a total station or survey-grade GNSS to verify the accuracy of the automated extraction. We have to prove the data is correct. Furthermore, our legal and ethical responsibilities demand it. When a surveyor affixes their seal to a plat created from a point cloud, they are taking professional responsibility for every single feature depicted on it, whether it was extracted by a human or an algorithm. This means we need to develop and adhere to rigorous standards and specifications for these new deliverables. We need to be able to state and prove that the automated extraction of a curb, for instance, meets a certain accuracy standard at a 95% confidence level. Without that statistical rigor, we're just making pretty pictures.
This brings up the central question about our professional future. If data capture and feature extraction become increasingly automated, what is the evolving role of the professional surveyor? Some might fear that technology will make us obsolete.
I would argue the exact opposite. Our role isn't disappearing, it's elevating. We are transitioning from being primarily data collectors to becoming geospatial data managers, analysts, and trusted advisors. Our value is shifting from the physical act of measurement to the intellectual act of managing, interpreting, and certifying the quality of spatial data. The world is awash in location data, but much of it is of unknown quality or accuracy. The surveyor of the future is the ultimate arbiter of spatial truth.
A perfect example of this elevated role is in the development and maintenance of digital twins. These are high-fidelity, continuously updated virtual models of physical assets, systems, or environments. A digital twin of a city, for instance, could integrate survey-grade base mapping with real-time data from traffic sensors, utility monitors, and environmental sensors. Surveyors are the only professionals with the foundational skills in geodesy, measurement science, and data management to build and maintain the authoritative spatial framework that these digital twins require.
That's right. And this extends to our most traditional and sacred duty, the boundary survey. While technology makes it easier to measure, the legal principles of boundary retracement, the evaluation of evidence, the interpretation of deeds, and the application of common law remain a deeply intellectual process. No AI can replace the professional judgment of a licensed surveyor weighing conflicting evidence to render an opinion on a boundary line. In fact, as spatial data becomes ubiquitous, the surveyor's role in providing this legal and authoritative context becomes even more distinct and valuable. We are the guardians of spatial integrity.
So, to thrive in this evolving landscape, we need an evolving skill set. The surveyor of tomorrow can't just be an expert with a total station. What are the key competencies that students and current professionals should be focused on developing?
On the technical side, data science skills are becoming non-negotiable. This includes a working knowledge of programming, particularly with languages like Python, for automating workflows, manipulating data, and performing analysis. Strong database management skills are also essential to handle the massive datasets we now work with. And more than ever, a deep theoretical understanding of geodesy and statistics is paramount for analyzing data quality and managing uncertainty from diverse sensor sources.
I would add that the so-called soft skills are becoming just as important as the technical ones. The future surveyor must be an excellent communicator. We need to be able to translate complex geospatial concepts and the implications of data accuracy to clients who are not surveyors, engineers, architects, attorneys, and city planners. We need to be consultants who can help them ask the right questions and understand the power and the limitations of the data we provide.
Absolutely. Project management and business acumen are the final pieces of the puzzle. The surveyor of the future will be leading complex projects that integrate different technologies, managing teams of specialists, and understanding the business case for geospatial investment. We need to be problem solvers who see the bigger picture, not just technicians focused on a single task. A commitment to lifelong learning is the only way to stay ahead.
So to summarize, the future of surveying is not about replacing people with technology, but about empowering people through technology. It's a future defined by an abundance of data, where the surveyor's core role evolves from data collection to ensuring data integrity, providing expert analysis, and acting as a trusted consultant for all things spatial.
It's an incredibly exciting time. The fundamental principles of measurement science, professional ethics, and our duty to the public remain our anchor. But the tools we use and the impact we can have are expanding exponentially. We are moving beyond the boundaries of the parcel and into the fabric of a spatially aware digital world. The future is bright for those who are willing to adapt and lead.
A fantastic perspective to end on. Debora, thank you for sharing your vision of the future with us. And thank you to our listeners for tuning in to Surveying and Geospatial Insights.